Hello, I am Dr. Brian Wright, and welcome to the first of a series of videos about data science. I think we're going to do an overview of a few broad topics, but first we're going to start here with data science to give you some context about the past, where we are right now, and then moving forward. As a quick introduction to me, I am an assistant professor in the School of Data Science here at the University of Virginia. I came down here from GW, where I also worked in the data science, founded a program there, and developed a research institute. But that's enough about me. Let's jump right into this presentation here. Okay, so I'm going to take this bubble and just move me down here. All right. So the field of data science has rather obvious roots in statistics and computer science. However, really the explosion that we've seen over the last 5 to 10 years has to do with industry and the rapid development of computing technology and research in the industry field. So it really is a combination of those two things. We'll talk more about that as we move through this. It seems like there's it's a thriving industry supported by numerous training programs and what seems like endless growth potential. And the future will largely see I think probably a move towards specialization, as we've seen in other academic fields, as business and computer science. And expansion, horizontally and vertically, and more depth is probably added into subdomains. And we'll talk about those subdomains and what we think data science looks like kind of moving forward. When I say we, I mean the data science school at UVA. Okay, so let's get into a brief history. You can see here, obviously, that according to the last couple of years, we've seen a crazy amount of increase in data science papers over the last 10 years in the big data area. Just kind of an analogous of what we're going to talk about. So we're going to go way back earlier to that. We're going to start in the 1960s here with Peter Noir kind of used the term data science as a substitute for computer science in a research survey. That's kind of the first time that we saw the immersion of that phrase. A lot of people consider this work by Tukey in '62 kind of the future of data analysis as the pebble in the pond that kind of launched a lot of thought in this place. For a long time he thought he was a statistician, but really, his ideas are centered around kind of data analysis and applied more to I think practical applications, empirical science, and the rise of this stored computer electronic resources, right? So he's talking about kind of applied data analytics. He uses the word kind of empirical, and then pontificates about the use of an expansion of the computer to do this type of analysis. So it's pretty interesting, given that it was nearly 50 years ago, or more than 50 years. So Tukey also described kind of 4 areas that seem to be contributing to this field, right? So again, it's new theories in statistics, acceleration of this computer technology. These are all items he mentioned in this kind of paper in '62. The challenges with larger and larger data sets. An increased emphasis on quantitative methods. Usually, I think these are oriented towards the realities of these, kind of top 3. These new theories, the advances in computer technology, and then also larger and larger data sets kind of required, adaptation of new quantitative methods. I mean, it's pretty amazing considering that this was over 50 years ago. So it's kind of, you could lay these as discrete items that are driving the field today. A really well-known paper in this area is David Donahue. He talks about kind of the 50 years of data science published in 2015. So I reference that here because much of what I'll kind of articulate was mentioned in his paper. And so he mentions John Chambers, Bill Cleveland, and Leo Bremen as kind of the large contributors to the evolution of data science. And it's largely defined in his idea about this movement away from theoretical applications and more into practical applications as data sets kind of grew larger and larger. In '74, we see Peter Noir publish a consensus survey of computer methods defining data science. I'm not sure it's a great definition, but he does work to define it. The science of dealing with data. It has been established the relationship of data to what is represented in other fields. So I think he's thinking about kind of the interdisciplinary nature with which all sorts of fields are dealing with constraints around data, or how they're using computational methods to analyze data inside those subdomains. In 77, we see the kind of International Association of Statistical Computing. They talk about modern computing technology. It was established, knowledge of domain experts, statistical methodology. All of these could be seen as kind of foundational pillars in the field we see today. So this was occurring back in the 70s. We see kind of these first three cornerstones of modern day data science, and maybe also articulated by Tukey. Jumping forward a bit, we see John Chambers here created the S language, actually, which will evolve into R, which is one of the most ubiquitous languages used in data science. Kind of wrote this essay on greater or lesser statistics, choice of future research, where he talks about increasing concentration away from traditional topics, based largely in data analysis and supporting mathematics. I won't read this exactly, but as a broader view of the concept of learning from data, thinking of it not as feeding into the theorems, but actually what can we feed out of it. So I think is what he encouraged, and basically suggested that there's lots of opportunities for statistics to kind of evolve its thinking away from theoretical into kind of a more broader context. So this is seen as maybe starting a real momentum towards this new area of practice in data science. And then William Cleveland wrote an essay, Data Science, an action plan for expanding the technical areas of the field of statistics. And this is very similar to what Tukey had been espousing to, and then also as we saw here with Chambers. And so and he defined some areas about what he thought this field might look like. Multidisciplinary was a big one, right? And then models and methods, computational pedagogy, tools, and evaluation, and theory still being a big component, but not necessarily the entire concentration of what this new field might look like. And so this, again, is kind of drawing a line to encourage the field of statistics to think more broadly. Him and Cleveland and Tukey really were drivers in this space. 89, we see Gregory Shapiro establishes kind of the first knowledge and discovery in databases, this KDD workshop, which is really started to create what I think most people would feel is a coalescing of like-minded folks in this space, created kind of a community around this workshops. And then this expanded, and so the International Federation of Classification Societies in Kobe, Japan, used data science in the title of their conference for the first time in 96. We're rapidly approaching modern day here. And then in 2002, this is really an academic history, as I suggested. We see a data science journal is launched, and then, not to be outdone, the Journal of Data Science is launched in 2003. So we can kind of trace these communities being developed to some of these first conferences or societies and workshops, and then I think as an evolution of that, you see some of these official journals labeling the field coming out. So Cleveland and Tukey and others were really trying to generate energy. They're trying to push the field towards adapting this larger perspective. But it really wasn't until industry started to generate some significant excitement around a new class of workers. The data scientists were coming out swinging. So Google, of course, weighs in January 2009. We see Hal Verheeren, Google's chief economist, say, I think the sexiest job in the next 10 years is going to be statisticians. And people think I'm joking, but the ability to extract data, to understand it, and he's almost creating a pipeline here of the data science foundation, right? To be able to understand, process, extract value, visualize, communicate. I mean, those could be steps in a data science pipeline. It's going to be hugely important. And he did suggest that we now have free and ubiquitous data. I think that's pretty funny from someone coming from Google, so I'm not sure that's totally true, but we did, this can serve as a market indicator, and I think it's really what Tukey and Cleveland and others were really trying to push forward. But like I said, as industry starts to weigh in, we have the official term data scientist, the sexiest job of the 21st century, by the Harvard Business Review. This was largely seen as a reflection of what G.J. Patel and Jeff Hambacher were doing, at LinkedIn and Facebook. They said they claim to have coined the phrase, which is totally true. But I think we saw from the history that the phrase data science had been around for a while, but they were applying it specifically to what to what they were doing inside those industries. And that's really what catapulted the contemporary industry that we see. And so I think if we distill down kind of this history into maybe 3 high-level bullet points, we see this growth of analytical capability, we see computing power, and then, I think one that people underemphasize is really the availability of open source software, whether that's Python or R or other really open source processing platforms, at least to a certain extent. There's a huge community of people contributing to these tools. And I think our ability to take kind of data science as maybe a more niched environment and instead expand it to huge populations of people is largely predicated on this open source revolution, really. I mean, and we see that continuing to grow with open source packages being available for all sorts of niche types of domains. And so there, it's really, I think in large part, I think that's a really contributing factor. Obviously, as AI and machine learning and all of that and the analytical space has grown, those are not to be understated. And none of this, of course, wouldn't be possible without computing power. So there are certainly 3 legs of the stool. But this one in particular, I see not maybe as talked about as much as it should be. So if we're fast forwarding to today, it's not a huge fast forward, but we are fast forwarding. We can see this, LinkedIn analysis of the job market. It's just gone crazy for analytics and job postings. Same with Indeed, a pretty well known now, I think, job posting platform. It's just the number of available jobs has just gone. I can move me here a little bit. Has just gone crazy over the last, and this is even, I'm sure it's continued to grow, but anyway, you can see that these curves are significantly upward trend here in the field. I think it's probably fair to say that, that we're starting to coalesce on 3 broad areas. There's probably other ones here, chief data scientist, kind of a C-suite level person might be something you add to this. But in general, we have business analytics, data science, definitely not totally predicated on arts and sciences, but maybe there's kind of an orientation there. And then data engineer. I won't go through each one of these, but a business analytics person is probably someone that's leveraging the outcomes of machine learning algorithms or some other type of model to make decisions. A data scientist is the one that's actually generating these models, and then broadly a data engineer is the one that's creating pipelines and infrastructure for these types of data to flow throughout an organization. So I think broadly that's how we can look at it. There's lots of options for how we can learn in this space, and this is an evolution of the demand, I think. So this is just what we're looking at now. I mean, actually, this presentation is another example as well. But we have immersion programs and traditional secondary education. We have online, whether it's Coursera started out as a platform for doing computer science and machine learning. It was one of their first courses. Then lots of people are bootstrapping on their own, and I mean that they're picking up free books or open source text. I mean, there's just a tsunami of available content, which actually makes it more difficult, I think, at times to sort through what's good and bad. But these are broadly, how we're how data science education is supporting the demand in the field right now. This, again, just kind of a continuation of what the job market looks like. We've got, this is a report out from PwC, I think in collaboration with the education, there's a collaboration with Wright Business Higher Education Forum, sorry about that. And so they're just kind of looking at different types of skills and how they would classify across these 2 different types. We kind of touched on these already, whether it's a data analyst, a data engineer, or a data scientist. Data scientists being the ones that can appear to do everything, but the demand actually is higher here than it is for data scientists currently. As we continue to look on, the same report here, PwC is very well known. They're talking about, you have to take this in context. There are 23% of educators say all graduates will have some data science or data analytics skills, whereas employers say, they prefer, 69% of employers say they prefer candidates to have these skills over ones without it. So I'm not sure it's an actual exact match from supply to demand in terms of the way they did the phrasing there, but it can be a kind of barometer to say, hey, look, we still have lots of growth when it comes, lots of potential expansion here when we think about what types of education we're providing to students and how maybe it can be embedded into all sorts of domains, as compared to the market, which already seems to be really wanting these types of skills. This is just a representation from that same study about where the demand is. And maybe this isn't too surprising. We can kind of see, if you do kind of a cutoff here about the major areas of data related activities, in large part in the San Francisco, California, New York, DC, Chicago area. I think Boston and Seattle should probably be pretty good areas too. But anyway, just kind of takes a quick look at where we're at in terms of total postings and then density of jobs available in certain cities. All right. So again, so it looks like there's going to be 2.7 million data science jobs will be present this year. It's a 400,000 job increase from 2015. Seems crazy. Indeed, again, we referenced them earlier. They see data science job postings jumped by 30% just in 2018. So I mean, it's really still just going up at an incredible rate. We see it's more than tripled, 256% since 2015. Certainly things are continuing to grow and have right now. So the market is really starting to mature. And so now we think about, and here's our we think about the future, right? So let's talk about that quickly as well. So I think what we'll almost certainly see is standards in the field starting to emerge, whether that's a certification of some type of professional certification, analytical professional. I think that will probably start to mature. There's already some of that going out already, but similar to other kind of quantitative oriented domains, you may see more and more of that. And so and this is not really predicting the future. This is already happening. The emergence of communities certainly start to become more discrete, whether that's data artists or sports analytics or marketing analytics. I mean, all of these things are already. I mean, there's a degree already, I think, out there on sports analytics in particular. And so that will almost certainly continue to grow. Computational linguistics is another one. So here, increased specialization is really just another bullet speaking to the one above. Domain areas will start to really concrete, I think, social media analytics, or it could be actually that there's specialization in terms of different analytical approaches, whether that's natural language processing. I mean, there are already a good amount of degrees in computational linguistics and NLP. Deep learning, without a doubt, and AI. And then also, as an example, potentially, human-centered design as we think about how people are designing these systems, which is already a very mature area, but could certainly be encompassed with certain data science disciplines. I think we'll also see lots of increased collaborations between the private sector and higher education. I mean, a lot of the really innovative algorithms or machine learning approaches or AI approaches, they're not being necessarily developed inside academia. These are well-funded, incredibly powerful labs that we're seeing in some of the big software companies. And so I think increased collaborations between, institutions and, the Facebooks, Googles, and Microsofts of the world will probably become more common. And maybe for the best. So an automation of machine learning, I think that's definitely going to happen. It already is. A lot of these traditional algorithms we're using, will be automated. I think a lot of the processes associated with just getting data ready or piping it will certainly not be. To a certain extent, I don't think that may ever will, but automation is probably something that we'll certainly see. And adoption of enterprise software, I think that's probably true. I hate to use the HR environment because I know there are thousands of different options there, but these, PeopleSoft and Kronos, kind of ubiquitous, I guess. But I do think that we'll see winners and losers in terms of AI platforms, and we already have in the cloud computing space with AWS, Azure, and kind of Google platform, and those are just represented by the three big, Google, Amazon, and Microsoft, three big companies. So I think we'll see more and more of that. I also think we'll see, rapid continued growth in computing power. I think we're kind of maybe on the verge of a quantum computing breakthrough. Hard to say, but I do think that that's a real possibility. And if that does become something more stable, that could really change, the development of AI and artificial intelligence. And so that kind of speaks to this next bullet here about an increased capability in AI and deep learning. I think it's really going to continue to mature. I also think that if we think about just policy implications, I think there's been a lot of pushback and a lot of focus recently on how large-scale decision algorithms can replicate human bias that are already present in our society. So I think there's going to be more emphasis on human in the loop. Who knows if it was just for show or not, but we know that Facebook is hiring thousands of actual people to check their news feeds and pictures and different types of algorithms they're putting out to make sure that the content they're providing is fair and balanced as possible. So I think you'll see more of that. There'll be more of an emphasis on human and computer collaboration and not just fully autonomous AI machines, and that might be a byproduct of increased legislation, like we're seeing in Europe with the GDPR. Increasing desire for people to have privacy and not be tracked all the time, and not sign over all their personal freedoms to the big tech companies. So I definitely think you'll see increases in that. So this is the last slide, but I do think I'll just say moving forward with this series of lectures, you'll see that they'll be oriented around this theoretical framework. This is something that we've kind of developed at UVA in the data science school. So what we think could be a framework for the field of data science. I won't get into the details of each one of these categories, but I do think it's important to say, when we think about the future, we do think that the field academically right now is fairly ill-defined, right? We think it's a collection of these different things, or maybe, it includes computational power and new models and machine learning and, all these different techniques. But as compared to other domains, whether it's, education or politics or economics, usually there are fairly discrete kind of disciplines. And so we think that this could serve as an attempt at that. And so we're designing our academic programs around this. And much of the, actually pretty much the entire video series here will be designed around this theoretical framework of the field, which in one of the next videos we'll get much more into. All right, thank you for your time, and take care. Okay, bye.
Hello all, thanks again for watching the video. We added this quick survey here for you, so if you could take the time and work through that just to give us some feedback on how things went today, we would greatly appreciate it. Thanks again, and I hope you continue to watch the videos coming up in the series. Take care.